Okay, so the first document that I'm going to share, you don't have access to. It's just a document I made to put up on the screen. But we have talked so far about what it means for a function to be linear. Okay, and we noticed the other day that that means that the slope is constant. In other words, the change in y over the change in x, right? So for equal intervals of x, y changes by equal amounts, right? You might have drawn slope triangles in high school. Actually, write the equation of this line. Pause the video if you need to, and write the equation of this line right here. Okay, so I pointed out yesterday that I assume most of you are the most comfortable with y equals mx plus b. We're going to want to change that because you're going to prefer slope-intercept form in this class, which we'll get to in a minute. But change of y goes up 1 unit for every 2 units that x changes. So our slope is a half, and our y-intercept occurs right here at the point 0, 1. So the y-intercept is 1. Okay, then the other day we looked at on a parabola, we found slope between 2 points on a parabola, and we realized that the slope was the steepest down here, and then the slope got flatter, and then at every different point along this curve, the slope was different. Okay, so linear functions are the function that has that unique feature of constant slope. Okay, so what biggest reason you're in this class is to learn how to find slope of functions that aren't linear. Just to say a little bit more about linear functions then, when there are equal changes, so if you buy apples, right, and they're $2 a pound, and you plotted this data, right, for equal changes of x, you get equal changes of y. Okay, this would have a slope of 2 and be a nice straight line. Okay. Often when we buy things in larger containers, for example, one of my colleagues has 6 kids and I ask him, how on earth do you do it? But when you can buy these great big huge tubs of stuff, right, it's more cost effective. Okay. You guys have these little mini fridges in your dorms and you have to buy the really small containers and you get less, your cost per unit would be much higher in the little tiny container of mayonnaise than it would be in this great big huge jug. Okay, so if we look at something like this and we look at, constant change in x, well, let's see, if x went up 10, this went up by 50 cents. Okay, so then that should tell me, well, then over here, x just went up by 3 tenths, more than 3 tenths, right? So then this should go up by $1.50, which it actually goes up more than that. Okay, and certainly if we look here, you buy 30 ounces, it's $5, right? And then you double this, and this less than doubles. And then actually to go all the way from the 64 ounce to the 120, right? We went up by 60 and we only went up by $1 something. Okay, so certainly we are not getting consistent change in y for the same change in x. Okay, so that would tell me that this was not linear, and a curve like this curve would look like this, right? That as you buy more, it gets cheaper, right? It's most expensive when you buy the smaller containers. So anyway, let me unshare that and then share the handout that you were asked to print, which is this one. Okay, so to start off, right, very first question, find the equation of the line. You're given the slope, you're given a point. when you know y equals mx plus b, and if that's all you know, right, then you could do this problem by saying, okay, I will take the m, which is -4, right? And then here's my x, and here's my y, and then I will plug those in, and I will get my b. Okay, you can solve for b in that way. And that would be a perfectly fine way to do this. We, however, are going to prefer what's known as the point slope form of a line, because there's going to be a lot of times in our class when we're going to have a point, we're going to have a slope, and we want to find the equation of the line. Okay, so what we do to get point slope form is, notice we take the slope formula, and all I've done is erased these 2's, right? I've just made this a generic x and y. Okay, so if you know the slope formula, then you know this formula. Okay, because take this, erase the subscripts from the first x and y. You could think back to middle school where you learned to cross multiply, or you could think multiply both sides by x minus x sub 1, and you get here. And I'm actually okay with you leaving your answer in this form. It's more common to solve for y, but if you left it in the form that is there to the left, I'm okay with that. So why don't you pause the video and do the problem below without a calculator, because I'm going to have you do some basic skills with integers on your first quiz and not let you use a calculator. Okay, so pause the video for a minute and find this equation of a line. Okay, so it doesn't matter, of course, which point you started with. Change in y over change in x. I hope none of you said that numerator is 3, right? Because if you lose 6, a debt of 6, and then you lose 3, that's going more into debt as -9. Or some of you learned that rule that subtracting is add the opposite, right? So you might have gone like that, right? Add the opposite, because we all know that minus minus becomes plus plus. So we get 9 over 1, so 9. Okay, then it makes no difference which point we decide to use. So if I wanted to use that first point and I wanted to write it in this form, okay, so I would do y minus y sub 1. So watch the double negative, right? Minus a negative, so that would become a positive, equals, the slope is -9 times, and then again, I get that double negative, minus -1. So that would become +1. So I'm fine with an answer like this. Or again, you could have used this point and you could have written it in that form. Okay, so using the different point and solving it for y, so we'd have the same slope. Let's see, again, watch the double negative. So that's x minus 2. So x plus 2, and then plus y sub 1, so that would be plus 3. And these look different, but these are exactly the same equation. Okay, so either form is fine. Now down here, I did steal this document from pre-calc, so some of this might be a little too basic, but if you wrote in these coordinates, you know, what we learned yesterday, and I think I really drove this point home, is that the y-intercept occurs, so when I cross the y-axis, it occurs when x is 0. Okay, and then the x-intercept occurs when y is 0. So this would be the point 3, 0. This would be the point -1, 0. Right? Then you're asked to graph some lines. And so I hope you recognize that these are either horizontal or vertical lines. This one might look weird, though. The line x equals 0. Like, what does that mean? Okay, but again, if you looked at what we labeled here, where is an entire line of points where at every single point, the x coordinate is 0? Where does that happen? Okay, but let's say you're working on y equals 2 and you can't remember, right? You know it's either horizontal or it's vertical, okay? And it's better to know how to problem solve and figure things out than it is to try to memorize. So you might try drawing either, and you say, well, I know it's one of these, so let's look at some points, okay? And this is the point over 4 up 2. Okay, that's a point on the line. Over here we have, say, -3 up 2. Okay, and then we went over to the vertical line and said, well, here's the point 2, -1. And here's the point 2, 4. Okay, well, I'm looking for the line where y is 2. Okay, on this line, x is 2, right? So this would be the line x equals 2, y values are 2 here, so this is the line y equals 2. Okay, so it's better to know how to figure out if you've done it correctly or not correctly than it is to just try to memorize, oh, it's always perpendicular to the axis, or whatever tricks you might have learned before. So I'm going to end with this, but please complete the rest of these on your own, and then we'll pick up with this after Wednesday.